Hello, Integrated Math 1. Welcome to Module 2, Topic 1, Lesson 5. We're doing the second half of the lesson today. You did the first half of the lesson last time. So that starts us off on Activity 5.3, where we're going to be comparing equations and tables. So Josh and Greg are friends who live in different countries. When they chat online and talk about the weather, one of them always uses temperature in degrees Celsius while the other talks about temperature using degrees Fahrenheit. I could totally relate to this because I, of course, live in California, which means we use degrees Fahrenheit. But often when I'm chatting with my friends back in Australia, they're using degrees Celsius. So it gets concerning when I tell them it's 100 degrees outside because they think that means I should be dead. So we do have to clarify that a little bit. So Josh and Greg has this lovely table here. Josh has this equation. So Josh uses the equation to convert Greg's temperatures. And Greg looks at a table to convert Josh's temperatures. The equation and part of the table we have shown down here. Now, something you might want to keep in mind is that you can either remember that water boils at 100 degrees Celsius, 212 degrees Fahrenheit, or you might want to remember this. If you've ever lived somewhere where it snows, you know this one. The water freezes at 0 degrees Celsius or at 32 degrees Fahrenheit. So take a look at this. It means that it looks like your Fahrenheit is going to be the bigger number compared to your degrees Celsius. So this is an important thing to keep in mind. So the first thing we want you to do is we want to know who's who. Who's dealing with who's. So first of all, identify your quantities in the table. You need to put a label here, degrees, whether it's Celsius or Fahrenheit, whichever one it is. And also in your equation, which one is the independent, which one's the dependent, which one's degrees in Fahrenheit, which one's degrees in Celsius. And then I got a question for you. Who is converting from degrees Celsius to degrees Fahrenheit? And who is converting from degrees Fahrenheit to degrees Celsius? Explain your reasoning. So I'm going to give you a few moments to think about that. Again, remembering that 0 degrees Celsius is 32 degrees Fahrenheit. That might help you out a little bit. So start with that and make sure you explain how you know who's converting from what to what, because that's super helpful to know. Go ahead and hit pause. Write your labels on the table, write your labels on your equation, and then see if you can figure out who's going from where to where. Hit pause to work it out. Hit play when you're ready to check your work. Okay, so I know that 0 degrees Celsius is 32 degrees Fahrenheit. So Fahrenheit is going to be a bigger number than Celsius is. So when I'm looking at Greg's table, I can see that the bigger numbers are over here and the smaller numbers, the lesser numbers are over there. So that tells me that this side must be degrees Fahrenheit and this side must be degrees Celsius on Greg's table. So it looks like Greg is inputting Fahrenheit to get an output of degrees Celsius, which means that Josh has to be going the other way. This means that Josh's input should be Celsius and his output should be Fahrenheit. So yeah, the output of Josh's equation, J of x, should be degrees Fahrenheit, but that input, that x, should be degrees Celsius then. So this helps us out with several things. And that makes sense because if I input is 0, that 0 times anything is 0 and I get 32. So if I input 0 degrees Celsius, I get an answer of 32 degrees Fahrenheit. This is good to know. And actually, this also helps us answer the question, who is converting from Celsius to Fahrenheit and who is converting from Fahrenheit to Celsius? Well, if you take a look, Greg is plugging in Fahrenheit and getting out Celsius. So Greg is going Fahrenheit to Celsius, and Josh is plugging in Celsius and getting out Fahrenheit. So that means Josh is converting from Celsius to Fahrenheit. So Greg is converting from degrees Fahrenheit to degrees Celsius, and Josh is converting from degrees Celsius to degrees Fahrenheit. Input, output, input, output. Fair enough. And it makes more sense, and it means that your friends in Australia aren't freaking out thinking that you're dead because it's 100 degrees Fahrenheit outside instead of 100 degrees Celsius. 100 degrees Celsius, you'd be dead. It wouldn't be good. All right, then. Now that you've done this, here's the next step I would like you to do. We're going to compare some of our different characteristics here. To start off with, I would like you for part A, I would like you to consider, compare our quantities here, and I would like you to tell me the slope for part A, and on part B, can you tell me the y-intercept for both of these functions? So compare their slopes for part A, compare their y-intercepts for part B. Hit pause to work out both A and B, and then hit play when you're ready to continue the discussion. All right. We can totally compare slopes here. First of all, Josh's is easy to do. So I'm going to start with Josh. Josh's rate of change is easy to find, right? It's next to the x. It's the 9/5. So the rate of change, or the slope for Josh's function, is 9/5. This just means that for every 5 degrees increase in Celsius, there's a 9 degrees increase in Fahrenheit. There are a few ways you could find the rate of change for Greg's table. You could totally use the slope formula and work that out, but that gets a little messy. I realize, though, that Greg is just going backwards from Josh. So if Josh's rate of change is 9/5, that means Greg's rate of change is going to be the other way around. Greg's rate of change is going to be 5/9. For every 9 degrees increase in Fahrenheit, there's a 5-degree increase in Celsius. So again, because Greg's just going backwards from Josh, that just means his rate of change, or his slope, will be the reciprocal of Josh's equation. That's fair. I hope you also compared the y-intercepts. On Josh, it was super easy. Josh's y-intercept was 32. Hey, that was an easy one to find. It was just hanging out there. So Josh's y-intercept was 0 degrees Celsius is 32 degrees Fahrenheit. For the y-intercept for Greg, it took a little more work. Probably the best way to do it would have been to have plotted those points on a table and then use like a ruler or straight edge and kind of lined it up a little bit. But it was a little rough to find the y-intercept for this one. I won't deny that. Again, plotting the points and then just making that straight line using a ruler or something like that to see where it hits your y-axis probably would have been the best way to do it. And you probably didn't get this exact an answer, but around there you should have found that Greg's y-intercept, the y-intercept for Greg's function, is about negative 17.75. So this means that 0 degrees Fahrenheit is about negative 17.75 degrees Celsius. And that's cold. That's well below freezing. That's super cold. I do recall a January in Bozeman, Montana once, many years ago, where we hit 30 degrees below Celsius, 30 degrees below 0 Fahrenheit. I am afraid to ask what that is in Celsius. Unpleasant. That's what it is. It's unpleasant. I'm not a girl who does cold. That was a bit much for me. All right, so let's move on then. So now that we've got Greg and Josh and their whole Celsius Fahrenheit deal worked out, let's talk about Michelle and DeAndre. So Michelle and DeAndre here on activity 5.4 both opened bank accounts at the same time. So at the same time, they both opened up their bank accounts. Hooray. DeAndre's account balance is shown on the graph. He started with $0 and deposited the same amount each month. That's why it's a nice linear function. In the fourth month, and I'm going to make a little note of that. So in the fourth month, this last one, 1, 2, 3, 4, in the fourth month, he had $80 saved. Good for you, DeAndre. So actually, I'm gonna even make a little note of that here. So by the time he hit the fourth month, he had $80 saved up. That feels useful and like something I should write down. Michelle opened her bank account on September 1st. Again, same time that DeAndre did. Michelle opened her bank account on September 1st with $25. Ooh, good girl. And continues to deposit $25 each and every month. So DeAndre started at 0, but Michelle started at 25. And we'll go from there. Great. So use what you know about DeAndre's account to determine the scale of each axis and interpret the origin on the graph. Explain your reasoning. So go ahead and hit pause. label your x-axis, label your y-axis. What are the numbers? What are the units? All that stuff. And explain to me what the origin is down here for DeAndre's graph. Go ahead and hit pause to work that out. Hit play when you're ready to check your work. All right, well, it said that in the fourth month, so 1, 2, 3, 4. So yeah, first of all, 1, 2, 3, 4. That makes it easier to do, which means we could keep going, 5, all that stuff. So in the fourth month, DeAndre had $80. 80, that's dollars. Sorry, I put a degree sign. How awkward. Let me fix that. So it said on the fourth month, DeAndre had $80. So it looks like we're counting by tens here, right? We got 20, 40, 60, 60, 80, and I can even go to 100 up the top. We also need to label these with their actual units. What is the x-axis? What is the y-axis? And so here, I'm going to erase, let me erase all this stuff. So it looks like this is our number of months on our x-axis, and of course the money we've saved in dollars on our y-axis. Hooray! And what about this origin? What does the origin mean? Well, the origin is 0, 0 here, and it means that at 0 months, $0 were saved. Fair enough. That's fair. All right, so let's compare once again, just like we did last time with our Celsius and Fahrenheit issue. Let's compare our bank accounts a little bit here. I would like you to compare the slope for part A and the y-intercept, that is the y-intercept, right? Yeah, and the y-intercept for part B. Compare your slope, compare your y-intercept for each of these functions for DeAndre and for Michelle. Go ahead and hit pause, write that down, and then hit play when you're ready to check your work. All right, well, the slope, what do we got here? It looks like we go over 1, up 20, over 1, up 20, over 1, up 20. Ooh, so I probably should phrase it better. Slope is rise over run, right? So we rise 20 for every 1 that we go over. So it looks like DeAndre's slope, or his rate of change, is 20. This means he saves $20 every month. Good job, man. Oh, and so if DeAndre's slope or rate of change is $20 a month, take a look at Michelle. It looks like it says she's depositing $25 each month. So I'm pretty sure that means Michelle's rate of change or slope is 25 because she saves $25 every month. Fair enough. Fair enough. How are your y-intercepts doing? Well, we already established that if you were to draw this line and keep that going, boom, it would hit the origin. DeAndre's y-intercept is 0. Which makes sense because he started his account with $0, right? He started his account with no money in it. So the y-intercept is going to be 0. That's fair. But what about Michelle? Well, Michelle did not start with $0 in her account. If you recall, when she opened it, she put $25 in it right from the start. So that tells me then that the y-intercept for Michelle's account is 25. This means that she started her bank account with $25. Fair enough. Fair enough. I think Michelle's a little more on her game with saving her money than DeAndre is. Although, good for DeAndre for saving his money too. That's good. That's good. Always good to save a little bit each month, guys. Tuck it away for a rainy day. You never know when it'll be useful. As always, I hope you found this helpful and I hope you found this useful. If you've got questions or concerns, please feel free to email me or ask me questions in class or come see me during office hours. I can totally help you. In the meantime, I'll see you later. Bye.